All right, folks, in this video, we're going to take a look at this Shnitpwr. It is an AC to DC converter. What I want to do in this video is determine, is this Schnit any good? Is this the type of Schnit that you might be looking for your ham shack or your electronics bench? It does look like some good Schnit, and I've heard some good stuff about this Schnit, but I don't know. So in this video, we're going to take a little bit of a deep dive. We're going to dig into this thing and see what we can figure out. It does say here that it's a professional power supply manufacturer. I guess Shnitpwr is the manufacturer. The model here is the SNT0312 through 120. Input of 100 volts to 200 volts AC, 50 to 60 hertz. That's standard here in North America, and this plug would handle that. Output is DC 3 to 12 volts, adjustable, 10 amps max. So this might be a handy little power unit that we could take advantage of here in the ham shack. Let's find out. PCBWay is holding its 5th PCB design contest. The timeline for the contest begins the 1st of September 2022 for the project release time. Project review time begins January 1st, 2023, and the winners will be announced February 6th, 2023. So hurry now. There are fantastic prize packages for first, second, and third place prize winners. Also a popular design prize and a participation prize of a Raspberry Pi Pico. The rules are simple. Enter today. All right, so here's the box that the Shnitpwr professional power supply came in. Let's go ahead and open this up and see what we have. Now, believe it or not, I have not looked in here yet. Looks like we come with a instruction manual. Let's get this Schnit out of here. I don't think we need this box anymore. All right, here we have some different connectors, and I'm going to assume they go on this end. They'll fix here. So here's a typical barrel jack that comes out of the Schnit, and you can take these different types of connectors. Like, for example, here's a USB-C connector. You can see that right there. And that would go here, and then you could use this to power a USB-C device. Here is your 110 jack, and just being candid about this, I would like to have seen this been a 3-prong plug with a ground plug on here. That's just me. I feel that would probably be a little bit of a safer device. And I have no idea what this is. This looks like it's some sort of extension into another type of plug. Maybe the instruction manual will have something about that. I don't know. But it looks like we have every size barrel connector that you might need to get the job done. And then actually here's one that looks like you can plug in some bare wire and then wire this up to something. Maybe you could put some power poles or something like that on here. And it's got the polarity marked positive and negative. I'm not sure if you can see that or not. All right, let's get this thing plugged in and see what kind of action we get. Okay, as we're getting ready to plug this thing in and see what's doing, there's something else here that I don't like. A lot of times with 110 power plugs, one of these will be a little bit fatter than the other one. And that's when you plug them into things like this, you don't get it backwards. I guess it really doesn't matter with the Shnitpwr. I don't know if that's good Schnit or not. But here we are plugged in, and we don't have our output connected to anything yet. So I'm just going to go ahead and I'm going to turn this on, just to get a look at it and see what's going on. I have not turned this on yet, so if it explodes, you'll get to see it here. So there's a very loud click when I turn that on. And right now, nothing is happening. Oh, there we go. And you can see this is kind of bright. It says 3.3. Let me turn this down and see what we can get. This is supposed to go from 3 volts to 12, and this is as low as it goes. You can see if I turn this, it kind of bounces back. So it looks like 3.3 is as low as it goes. I don't know if that's a problem or not. It's not for me, but it might be for you. As you can see, as we turn this up, we get a higher voltage. So let's just go all the way and see what happens. Well, that's fantastic. It goes up to 12.3, which I think is pretty good. I was originally concerned that this might not be something that I would want to use for like powering ham radios, for example. You have to really take a look at whatever device you're going to power and then make sure that the voltage is appropriate. Most devices will say, hey, this runs off of 12.2 volts, for example, plus or minus 3%. So that'll give you an idea of the range that you can use. What I want to do now is I want to hook up a multimeter to this and see if this reading is entirely accurate. So what I'm going to do is I'm actually going to turn this off. I'm going to get out the multimeter and we're going to set it up. Okay, so here you can see the multimeter and it is set up and connected. One of the things I wanted to note is that when I turn this on, it comes on just fine. When I turn it off, let's see if it does it again. It's off right now, but it is still showing voltage coming through. So it doesn't turn everything off at the exact moment that the switch goes off. And then I noticed that it would blink a few times. See that? So it doesn't auto power off. Is that a problem? I don't know. It's just something that you probably need to be mindful of. Now, what it said here is that the center pin was going to be our positive, and the outer shield of the barrel was going to be our negative. So let's turn this on and let's see if we can get it right around 5.1 volts, which is about what you would use for USB. So there we are, 5.13. So let's just go ahead. And that is right in the way. So we got 5.13, and then on the multimeter we got 5.14, and that is close enough. One of the things that I'll say is that with electronics, electronic components, everything's got a little bit of a fudge factor. Everything's got a little bit of a tolerance, and it'll say it's good within X percentage of. So I'm not worried about that at all. Let's go up to see if we can get this thing at 9 and see what 9 volts will show us. That is another very popular voltage that we use. There we are at 903. So when I put it on here, it looks reasonably accurate. I'm not going to complain about that at all. So far, I'm digging this Schnit. I like the Schnit. Let's go all the way up. And this should take us to 12.3. And let's go ahead and test that. And we have 12.23. And again, I think that's close enough for me. When I'm talking a little bit about the Shnitpwr, so far, the only thing that really concerns me is that when I turn it off, it doesn't really seem to go off. It takes a little while to warm up, I guess, when it comes on. I don't know if that is a result of, there's probably some big old capacitors in here that allow you to store power. This thing says it puts out 10 amps, and so we're going to hook this up to some equipment. I don't know how we're going to do that yet. And we're going to put a load on here, and we're going to see how well it does that. But what I wanted to do is we had this extra cable, and I did want to test this. And what I suspect is that this is a polarity reverser. So when I put this in here, and then I don't want to shock myself. And then when I put the ground on here, we get a negative voltage on our multimeter. And so that's saying it's negative 12.23. Here it's saying it's 12.3. So that tells me that this is in fact for reverse polarity. So if you do have a device that has reverse polarity input, then you want to make sure that you save this cable. All right, let's turn this off and let's see if we can figure out a way to hook this up to some sort of draw tester or load tester. We'll be back in a few. And here we go. It's off and it's taking its sweet time turning off. All right, folks, we're back, and I have to tell you, this probably isn't the best idea that I've ever had. Here we have a load that allows you to test the draw off of a battery or power supply like this. I have it coming out of here into some power pole connectors, coming over here into some unshielded alligator clips, and here coming off the barrel connector of the output of the Schnit. I just have a couple of wires that I put on here with ferrule connectors. Here you can see the same thing for the negative. We're going to try to run 10 amps through here at 12 volts. And one thing I'm going to say is that this wire probably is not the best wire for that. So we're not going to do that for very long. What we want to find out is that if we were using this to power something like an amateur radio, for example, we have to maintain our voltage at a certain current draw when we produce a signal. If we have too low a voltage input into our radio, we're potentially looking at damaging that equipment. Amateur radio equipment isn't the only equipment that can be sensitive to fluctuations in voltage. And that's what I'm most concerned about here. So we're going to attempt to replicate it with this $60 load as opposed to a $1,000 radio. We're going to turn this on. You can see I've got everything taped into place for safety. I'm not exactly sure that is an OSHA standard, but maybe it should be. Anyhow, let's test this Schnit out. I'm going to go ahead and I'm going to turn this on. And when I do that, we should start to see some, well, let me see what I can do here. We're not seeing any power over here yet. Okay, we're back, and this is on because I have the power cable plugged in, and it is not drawing anything yet. So I have this turned all the way down. Let's go ahead and turn this on, and we should start to see the voltage come through here, and we do. It's reading 3.23. Here's 3.30. I'm going to say that the margin of error is probably on this load tester side, as well as some of the resistance that we're seeing, especially through these cables. What I want to do is I want to turn this up to around 5 volts, and I want to test it here first at a couple of amps. And we're at 5.7, and that's going to be good enough for us. Here I have a coarse and a fine tune. So let's go to, oh boy, we're higher than I expected. So one of the things here is we're drawing about 3.5 amps, which is fine. Here it says 4.94 volts coming out, 4.06. So when I look at that, that's almost a voltage drop. Now that could be because of this. What we could do is we could test it with the multimeter. Give me a second. All right, you can see the multimeter's down here in the corner. I'll try to stay out of the way, but I can't guarantee anything. The first thing we're going to do is we're actually going to test this at the load and see what we get. So it says 4.06, so what's hitting the load and being registered is accurate. So what I'm going to do is I'm going to come up here and we're going to test it at the source, and this will tell us if it's these janky wires that we're using. And that says 4.19. Now on the Schnit it says 4.9. So under load, what we are seeing is voltage degradation coming out of the Shnitpwr. And that's probably not the best thing. We're going to keep this at 3.5 amps, and we're going to go ahead and we're going to turn this up to, let's say, 9 volts. The tuning on this is really tough. So here we are at 9.1. This is saying 8.1, so that's a full volt at this point. And let's just go ahead and test that here. Oh, let me get the multimeter back in action and let me move out of the way. And see, we're seeing around 8.27. And this is reading 9.1. So again, we're seeing some, I don't know if they call it sag or drop or whatever it is. Let's go all the way up to 12.3. And here we're seeing 11.2. So again, it's about a voltage difference. I don't want to cause problems, but we're going to go ahead and we're going to turn this up a little bit more. So this is at 5 amps. And you can see that this is starting to drop considerably. Like right now it's at 10.6. Here it says we are at 12.3. So that's almost 2 volts difference. Let's go up to 7.5. Oh, now we're beyond that. We're at 8. So at 8 amps, we're still seeing about 2 volts difference. If we just go up to, oh, well, look at that. We're drawing 11 amps. This is only supposed to put out 10. I'm going to turn that down because it's smoking. All right. you can see it smoke. I don't know. Oh boy, something's melting. I'm going to hit pause for a minute. I'll be right back. All right, folks. I don't know what you call that, but let's talk about this Schnit. So we did turn it on. We did test it. We put some load on it, and we went above the 10 amps. Was that the problem? I don't know. Maybe it was that we were trying to push the 10 amps through this particular piece, and we would not have gotten the smoke show. There is some stuff on here now, and this was very difficult to pull apart, so I'm thinking maybe some of this plastic melted. We had not gotten the smoke show if we weren't running it through this device, and I don't know. I read the voltage off of here before the resistance of the wires. I don't know if that was part of the issue or the challenge or not. This comes in a couple of different models. They have one that goes to 24 volts and only does 3 amps. I'll include a link to this below if you want to buy one. Seeing it overheat like that quickly, I don't know. I don't necessarily know if I like this thing. I'm just being honest about it. I know that some folks like these and some folks use these. I don't think I'm going to be one of those folks. Now, would this thing be fine if I was charging cell phones or doing some very small, light work with it? Maybe. I don't know. I do have a desktop power supply that I usually use for those kind of things. So I didn't need this. I did see somebody, one of my buddies was talking about this, and I found it intriguing, and I wanted to mess around with it. And I got my answer. One of the things the way one of my beliefs is that if something's dangerous, just don't mess with it. You know, you can't leave it unattended or any of that kind of stuff. And the way that escalated that quick, I'm just, this Schnit is not for me. So we're going to leave it at that. Maybe this Schnit's for you, and there'll be a link in the description below. Thanks for watching, everybody. I appreciate it. If you have any questions, comments, suggestions, or recommendations, go ahead and leave them below, and I'll do my best to respond.